Hello everyone, welcome back. My name is Victor, and yeah, welcome back to Senior Mathematics. We're gonna go 3 dimensions. Uh, Now, we're gonna be learning about 3D vectors, and we're gonna learn about magnitude and all the good stuff relating to dot products. Because vectors are the language of physics, engineering, and computer graphics, and the dot product is one of the most powerful operations you can perform with them. Um, what does this mean? A vector has two properties. Uh, they have a length and a direction, which points to where they will literally go. We write a vector as a set of components. So vector A here, as you can see, the components has 3, 1, 2. That means that it goes 3 units along x here, 1 along y, 2 along z. Now, I of course preach a rule, a habit. When in doubt, you have to draw them out. So these are the 3 axes. Yep, right here. You can walk 3 along x. So let's just imagine like this is 3 right here. This is a 1, and this might be, I don't know, 2 right here. So this could look something like this. Actually, I'm mapping that out a little bit, not too accurately, but you get the gist of the point. Where if you were to map these points out, you have those vectors. So those are vectors. What about the magnitude? The magnitude basically means like this, the length of the arrow. So Pythagoras is really extended into like 3 dimensions here. What you want to do is you want to square each component, square x, square y, square z, square them, add them together, and square root them. So that means that if we want to calculate something like the magnitude of vector A or something like that, then we would have to add all of its components together. So let us just write that out here. So we have to write, I mean, it's already written out for us, really, if you look at that. Why we're scaring? Because all these components here, and so if we have this, we just add them together. 9 plus 1 plus 4, this will be square root of 14. Pretty simple. That's for A. Now for B. If we want to write B, I need some other space here. I mean, it's pretty easy to calculate this. So B would be 1 squared plus minus 2 squared plus 3 squared. This would be 1 plus 4 plus 9, which is going to be basically square root of 14 and somewhat the same. So in terms of magnitude, still the same, even if with negative coordinates. So yeah. So it's a little bit of an interesting coincidence here. So both vectors have the same length, but they point in different directions. So that's for magnitude. What I want you to continue is look also at the dot product and the angle. This is going to be a little bit sophisticated here. So we know from our previous page that the magnitude of A and B for both these vectors is square root of 14. Now what we want to do is to write the dot product formula. We have a formula here. We basically multiply these components together correspondingly, of course, and they add the results. So let's multiply them together. We have 3 multiplied by 1, again, the x of A with x of B, plus 1 multiplied by minus 2 plus 2 multiplied by 3. We will have is 3 minus 2 plus 6. What we have is 7. Pretty simple. So the result is actually a scalar. It's a single number, but it's not a vector. Okay? And the power of the dot product is that it connects the angle between 2 vectors. Cosine theta, right here. What we want to do is that we want to find the angle between these vectors. So even if you do this calculation, it's not over. You need to find these values, these 2 values as well. So cosine theta equals A dot B divided by the product of the magnitudes. So let's write that out together. We know A and B equals how many? 7. Now let's just write that in. I'm going to delete this. Now I want to calculate cosine theta. And we also want to have a habit of writing what you know and then writing what you need. And so I've written out what I know already. So like A multiplied by B. The dot product I have is 7. And then the magnitudes here, which will be square root of 14. Wrote that. And now I need to know what is theta. For that to happen, I also need to know what cosine theta. Because if I know cosine theta, I can calculate what is theta, which is the angle. So I need to solve for this. So I need to solve cosine theta. Luckily, we have our formula right here and the values that I've figured out already. So we have 7 multiplied by, actually divided by square root of 14, square root of 14 as well. This will give us 7 over 14, which is 1.5. Now, because cosine theta is 1.5, I need to calculate theta, which is the angle, cosine theta. Sorry. I have the formula here, which is cosine to the power of -1 of -1 of 1 over 2. And this will give us 60 degrees. This is usually the calculator stage, where you calculate like what's the angle here and everything like that. The angle also, if you find this theta, you will know, okay. So the angle between these two vectors right here that we just had in the very beginning is 60 degrees. What does 60 degrees look like? Well, in a pure x and y plane, they should look something like this. This could look something like 60 degrees or something like that. But on like a XYZ plane, then I'm not able to like do that and demonstrate it live, but 60 degrees is something that you will learn later in the later videos as well. But right now we just need to learn like what are the dot products, what the angle, and is it perpendicular? Really, like is it perpendicular? Okay, so we have known for these two. What we do need to do is need to check by substituting them back. Of course, we need to know so we don't lose points. Of course, so I verify. I'm gonna verify it here. Down here, this is like a tradition at this point, where we verify in other parts for our working notes. So magnitude of A, magnitude of B, cosine 60 degrees. This will be square root of 14 multiplied by square root of 14, which is basically 14 at this point. Cosine of 60 is 1.5 of that. And this will give us what? This will give us 14 multiplied by half. This is basically 7. And so 14 times 1/2 is 7. This is matching our dot product. Confirmed. This is correct. Now, what we also need to be mindful of is a perpendicular test. So I'm going to write here. Now, I think I'm going to write somewhere. Yeah, I'm going to write it here. So if you find that the dot product A multiplied by B equals 0, then you automatically know that this theta angle is 90 degrees. You automatically know that it is perpendicular. Perpendicular. This is the rule. This is like a shortcut. And our dot product that we had was 7. It was not 0. It was not 0. It's larger than 0. So we know for a fact that it is not perpendicular. I'm going to write this in a shorthanded way where I write the theta angle is not 90 degrees, it's 60. So it's a critical special case, of course. This is going how you test it algebraically. Our vectors have a dot product of 7, so they meet at 60 degrees. And yes, so that is going to be a little bit of a shortcut if you find that there's a special critical case of dot product being equal to 0. Otherwise, this is pretty basic and pretty simple math with the whole vectors and everything like that. It can be looking a little bit confusing with this, but again, it's just algebra. So that is the end of the video. I will come up with more videos in the future, of course, and I'll see you again. Thanks for watching.